In this video for our Mock 7 review, I'm going over the second half. So I'm starting at now number 14 and going to the end at number 25. So with 14 and 15 with our real world applications, make sure here that you're identifying those important pieces. So like for example, I notice I'm given the formula that is involving side length of a metal cube given the mass and density. So I notice right here, that's my formula. So I'm going to go ahead and rewrite that. So I have S is equal to the cubed root of M divided by D, where S is what? The side length of the cube in centimeters. M is what? The mass in grams. And D is what? The density. So now keep in mind identifying variables. So now once you're given the values here, we can identify and relate to what variable it represents. So if a gold cube has a mass of 1,200 grams, so what does that 1,200 here, 1,200 grams represent? Well, that's your mass. That's 1,200 grams and mass, so that is M. And a density of gold, which is 19.3. So now notice we also have 19.3 grams per cubic centimeter, which means here, what does that represent? Well, that represents the density, which is D. The question is asking, what is the side length? So we are looking for S. So now make sure we just need to substitute and solve. We're looking for S, we don't know what that is. So we're going to leave it. S is equal to the cubed root of 1,200 divided by 19.3. And so once you put all of this in the calculator, we are giving the side length to the nearest centimeter. So here, S, the side length, is approximately 5 centimeters. Now, the next question, we have the height of a free falling. So here is our formula now that we're going to use for this problem, for the height of a free falling object, where H is equal to V squared divided by 2V, where H is the distance of the, so height in meters, V is our velocity, and G is acceleration due to gravity. And then, sorry, that's just kind of like a repeat of what we have here. The value of G depends on the which body or planet. If an object on the moon falls from a height of 31.85 meters, so what does this value of 31.85 meters represent? Well, if it says height, and this is your H, then here where the gravity is 1.5 meters per second squared. So what does this 1.57 now represent meters per second squared? Well, this represents here that due to gravity. So this is G, acceleration due to gravity. At what velocity will the object hit the surface of the moon? So we are looking for V, velocity. So let's make sure that we plug into our formula correctly. So in this case, H, well, H is equal to, so that's 31.85, because that's your H here. That is equal to, we don't know what V is, that's what we're solving for. So you leave it, V squared divided by 2 times G, which is 1.57. So really what we're going to go through and solve here is 31.85, which is equal to V squared divided by, let's go ahead and multiply, which this will give you 3.14. Now notice we are solving for V, but V right now is being divided. So we're going to save that exponent for last. It is being divided by 3.14. So now we need to multiply both sides by 3.14. So now here, when that cancels out, we've got V squared, which is equal to 100.009. Now notice we can solve for V. Well, if it's V squared, now we take the square root. Here canceling out, and V is approximately 10. Then question 16, we are given this formula here for electric power. So P is equal to, that's I squared times R. What is the equation for current in terms of power? Well, if we don't know what the variables mean, looking at the answer choices, what do you notice? What variable are we solving for? We're solving for I. Notice how I is being raised to the second power, so we have to save that last. And right now it's being multiplied by R. So first we need to divide both sides by R. Once R cancels out, I now have P divided by R, which is equal to I squared. Now we can get rid of that exponent here, solving for I, and take the square root. So that leaves you with the answer of B. Now, question 17, we're looking at the transformations. Notice how here we are translating the cubed root of x 3 down. Well, so far, all of them have -3. Then stretched horizontally. Remember, horizontal is inside the radical and opposite. So this is making here, if I have b is equal to 4, that means inside the radical, we need 1/4 to show that factor of 4. So I'm going to mark off A and C. Then translated 5 units to the left. So remember left and right, which is inside, again, opposite. So x plus 5 shows to the left versus x minus 5 shows to the right. So that's why here the answer is B. Then question 18. Same thing, we're taking that parent function, we're translating 2 to the right. So I'm going to go through and identify, because again, we're looking at the inside. This is opposite, so this is 2 to the right, 2 to the left, 2 to the right, and 2 to the left. So I'm going to go ahead now and mark off C and D, because we're going to the right. Now we're down to A or B. We're compressing vertically. So remember that vertical compression or stretch is now outside the radical, which means we're going to leave it as that 1/3 outside of the radical. That means here with vertical being outside, the answer we're left with is A, because B shows horizontal. And that's actually by a factor of 3. But let's keep going to check to make sure that everything matches with our answer of A. We are translating 1 unit up, which means I need +1 on the outside. So far, so good. And a reflection over the x-axis, which means we need that negative on the outside of the radical, which also matches. So the answer was A. Now, question 19. Remember, with our cubed root function, we're always starting at 0, 0. Notice how here that middle now got moved here to -4, 0, which means we went 4 to the left. So now let's look through to see which represents 4 to the left. Remember, inside, opposite. So this is to the right. Here, that's 4 to the left. Notice how this is outside, making that 4 units down. And here, this is also 4 units to the left. So I can go ahead and mark off A and C. Now look at the parent function. Remember, this full graph, this is the cubed root function. So that means here, that's why the answer is B, because notice how here, this is showing the parent function of the square root. So that's why the answer is B. Now, if you ever want to make sure, guys, to check, remember you can also graph in Desmos. So let's make sure that everything matches. So you could graph this in Desmos. Notice how here we're going through -4, 0. So notice how our graph here matches what we now have here as well. I also notice that we're just below that, crossing the y-axis here at 2. Notice how here we're below that value of 2. So again, everything matching. So the answer is B. Question 20. Now here we're identifying the transformations. So notice how here we have 1/5 on the outside, which shows vertical, but in this case, this is a vertical shrink or compression, and keep it where the value of A is 1/5. Now notice everything else is inside the radical. So with that negative on the inside, we are now reflecting over the y-axis. So we're flipping over the y, and then notice here, x minus 3. So again, think opposite inside the radical. So that's not 3 to the left, but 3 to the right. Now, we could graph this as well just to check, right, in Desmos. So here we go. Graphing in Desmos, I notice here, notice how it shrunk, so that matches our vertical shrink, so it's flatter. We also reflected, we're no longer going to the right here, we're now going to the left. So we reflected over the y, and now notice how we moved 3 here to the right. So that matches. Now, I just kind of put this in here. What if the parentheses, because we hadn't really talked about this, so I just kind of wanted to bring this up. What if we still had the 1/5 and we have the negative on the inside, but I take the parentheses away and you have just x minus 3? Do you think now by taking the parentheses away, this is still going to be 3 to the right? So if I were to graph this without parentheses, notice what happened. This actually went 3 to the left. So how is that if this is now all of a sudden 3 to the left? Here's why. Because here we have to make sure if you have multiple operations inside of the radical, we have to have this value here in parentheses, meaning as if we are factoring out. So if there's no parentheses, that means we need to factor out a -1 because that's the common factor. They both have a negative. So if I were to take out a negative or the -1, that means now 2 negatives making a positive and 2 negatives also making a +3. So now notice here really this is actually 3 to the left, which matches what you did here and what happens to the graph. So keep that in mind, that difference between here, if you had with and without the parentheses. So now question 21 and 22. 21 and 22, we're using the graph here. So 21 is talking about the domain and range of the graph. So I'm just going to start with my starting point here, which is at 7, 2. This is my x, this is my y, and continuing on in my direction. So remember, domain is always x values, which in this case starting at 7, and the range is the y values, which in this case starting at 2. So I can go ahead and mark off A and C because the values got switched. Now, domain, remember, is always the left and right, like the x-axis. So from the starting point, we're going to the left towards all the negative. So this is less than or equal to, and going down towards negative, which is also less than or equal to. So that's why here the answer is B. Then question number 22 is asking which statement is true. So now we're looking at the intervals, which is the x values. So first off, remember that here we always read the graph from left to right. So is the graph increasing or decreasing? Well, notice we are going upward. So all of these values are increasing. So I'm going to mark off A and B because these say decreasing. Now we're down to B or C. Here we go. So over the interval from 0 to 2. So remember, this is your x values. So from 0 to 2. So we're looking at this portion of the graph from 0 to 2. Notice how this portion of the graph is below. So the y values are negative, but this says positive. So let's check to make sure that the answer is C. We're looking at the X values from 4 to 7. So we're looking at this portion here of the graph. Notice how here, this portion, the Y values are above in the positive, which matches. So the answer is C. Question 23. Now I could graph this, but I do also notice if I want to know what's the domain and range. I notice that my parent function, y is equal to the cubed root of x. Notice how we have the cubed root. Remember, cubed root is that full graph here, no matter if it's going here or even reflected. No matter what, the domain and range is always going to be all reals, or from negative infinity to positive infinity. Then question 24. Notice how here we're looking at all of these characteristics. So I'm going to go ahead and identify again that starting point. So here we're starting at 3, 0, my x and my y, and going on in this direction here. So the end behavior, so as x's are approaching infinity and as x's are approaching negative infinity, what are the y values approaching? Because remember, f of x is another way of saying the y values. So here, as we're going to the right towards positive infinity, notice how here we're stopping on the right side at what y value? 0. Notice how we're not going past that y value. So f of x or the y values are approaching 0. Then as x is approaching negative infinity, so as we're going to the left, notice how here the left side of the graph is continuing on going up to positive infinity. Then the domain and range. So again, the domain is the x value starting at 3, and the range is y values starting at 0 from our coordinate here. Then again, domain, remember that's your left and right, just like the x-axis. Notice how from here we're going to the left towards all the negative, which is less than or equal to. Then from here we're going up, which is greater than. So the y values are greater than or equal to 0. Then last is the interval. Let me go back to my point here. So we're starting here at 3, 0. That's our point. Read the graph from left to right. Notice how here, what direction now are we going is the graph or the values? We are going down, decreasing. So we don't have an interval of increase. We only have an interval of decrease. Starting at the x values, so starting all the way over in negative infinity and going all the way and stopping at what x value? 3. Remember, your interval focuses on x values. And then question 25, notice how make sure, right? We're going to read and we're looking for which statement is false. So here, let's check A, if the graph is increasing over that interval. Now here, notice, read it left to right. What direction is the graph going? Down. So we are not increasing, we are decreasing. So this statement is false. So let's check to make sure that the answer is A and that the rest of these are true. The domain, it says here, negative infinity to infinity, which is all reals. So again, notice how we do have that cubed root function. So this statement is true. Then here the end behavior. As x's are approaching positive infinity, what direction is that right side of our graph going? Down to negative infinity. So that matches and this statement is true. Then as x's are approaching negative infinity now, so as we're going to the left, notice the left side of the graph is going up to positive infinity. So this statement is also true. So the false statement is A.